Hi, can you hear me? Anybody? Can you confirm?
Yes, sir.
Okay. Okay, we will start in 1 more minute. Okay. I guess more students need to join, but we will start because it is already time. Um, so yeah, welcome to the last week of our course. So already we have studied physics and chemistry now. So turning to mathematics, which is in some ways, I said this at the beginning also that maths is like the foundation of lot of engineering that we do in other subjects also, and so it is especially important in that way. And also, it is important from my perspective because let me just share my screen. Okay. So maybe some of you are joining this course in between, so you may not have got a chance to get to know about me. So just to show my information again. So as I said at the very beginning, although I started with physics because I had scored actually more marks in physics than mathematics in my own JEE exam. So I know how to score in physics well. But my own background and interest is more towards mathematics because all the work which I have done with Olympiads, for example, and in general, what I feel is that maths can be an important foundation for any engineering topics that you do. The kind of mathematics you do will differ based on which engineering branch that you go in the future. So it would be very interesting to have that discussion with you also. That uh, depending on what where your interests lie, because maybe many of you might already be doing some programming and are interested to pursue something like computer science, for example, but maybe somebody else is thinking of mechanical engineering, somebody else is thinking about becoming like a research academia, like a professor or something like that in physics or some topic. So each of these have slightly different requirements for the mathematics background. But what is common is the sort of the what we study for the JE is the sort of baseline from where you need to branch off into your own respective fields. Okay. So in that respect, I think mathematics is a very important starting point. And you will come to realize this in the next 2 years also. Like wherever you do your JE preparation, uh, maths is not important as a subject just because it is one of the three subjects in for your JE, but because it has implications for chemistry and physics also. Okay. Uh, so before we start with our discussion, this is something very important which I want to share with you. That what is the purpose of this course in general. I mean, maybe we should have done this at the very beginning of the course, but better to discuss it now at least. That so throughout this course, I think you are realizing that you are learning lots of different things, such as how to categorize a question in various topic or subtopic, how to try to analyze the question, like what are they trying to ask, what are the important problem solving ideas that are used in various cases. Along with that, you're also learning some good habits like how to manage your time properly, how to prepare good revision formula sheet and things like that. So all of these are, I hope, that helping you to become a better student through this program. But at the same time, please keep in mind that this is a very short program, and we are focusing on exam preparation, but that is not the entire story. you know so the second half is also important to remember, that it is not just about exams. Finally, your preparation is for anything that you're going to do in the future, which will be much broader than just any exam or any curriculum, right? So, you're always going to try to learn new topics because, you really appreciate the subject, and don't treat the exam as the end goal. That, every time I'll prepare for the exam and sort of almost over prepare for exam. Like, some students try to do this. Like, I will try to find out which are the most likely questions, and I will do only those. Like, I guess in 10th standard you have this, like, 21 most likely, 21 apexit Marathi book, maybe you know. So that is the kind of over preparation for one exam or the other exam, which in the short term will give you very good results, that you may do, much better than somebody else in that exam. But what happens after that? Because that is the more important question. You don't want to be in a situation where you over prepared for an exam and you cleared the exam, and then what was going to come after that, you are completely not prepared for. So, for example, if somebody, studies very hard and clears this exam, this JEE entrance exam, and gets your admission in the course of your choice, but then you find that the difficulty level is, you are not able to meet it at all, then it means that you are in the wrong place. So there is a risk of that happening if you just prepare for exams and not try to pick up the important learnings along the way. Okay, so I mean, use everything from our course to become a better student, not a worse student. Okay, and don't lose your good habits of learning to appreciate the subject, learning to think critically, and everything that comes along with. Same goes for tools like, for example, last time, if you remember, I showed you how to use some software like Blender to, do 3D experiments, or use ChatGPT to, run or generate more practice material. So all of these tools is always good to be aware of, but don't become too reliant on just the tools, so much that you lose your own thinking ability. So always try to balance this. This is very important to emphasize. Okay, especially for a course like this, where honestly we are not used to these courses, that in 3 short weeks we are able to prepare you for one exam. Typically, as you know, in MPI, students join at 8th standard and they are studying for 3 years for this 11th standard entrance exam. So that is a very long marathon. Okay. So so put yourself into the habit of developing the sort of long term thinking. Okay. Okay, I hope everybody is understanding the message. Okay, so then, coming back to what we want to do right now is again focusing on solving the problems. And in fact, we looked at these points earlier also when we're doing the physics, right? Because the fundamental approach is the same whenever you are solving a problem, that you have to convert the sort of the word problem, or the problem into variables. Then you need to solve the variables, like apply the important formulae or do the simplification, and then finally convert the answer back into the original problem, right? So these are the step 1, 2, 3 are the same as what we had looked for physics also, but some details change from topic to topic. So one of the things that is important when you are solving the mathematics is that uh, make sure that you choose the least number of unknown variables. Okay, so this point we will illustrate this in the problems that we do. That if there is a diagram which has lots of information, uh, which variables do you assume? So, I mean, that choice is very important. Just to give you one small example. So, for example, if let us say you have a triangle, okay, and you have the three angles of the triangle. So one could, for example, assign a different letter to each angle. So I'll call this angle as alpha. I'll call this as beta. I'll call this as gamma. So I have three variables in my problem. But remember that the sum of the angles is 180 degrees, right? So in fact, one of the three variables is kind of redundant. So this all again goes back to the idea of the degrees of freedom that we had talked about earlier. So actually, like, this gamma could be replaced by 180 minus alpha minus beta. So you don't require three variables; you require only two variables, right? So this is looks like a very trivial step, but many such small simplifications are going to reduce the number of unknown variables and make the problem easy to solve. Okay? And this is going to become more and more evident as you go for more difficult problems. Okay. Okay. So yeah, I will see more examples of this. Second point, very important, is use all the information from the problem statement, because sometimes there is just one word or one phrase in the question which is going to suddenly change the whole landscape, or give you some important hint that which direction you are supposed to think. So all of that comes from this. Okay. Uh, yes, Harshvardhan, do you have any comment? Okay. Okay. And then the third point is again very specific to mathematics, because we'll more and more often have topics which or questions which combine multiple topics. Okay. Like you may have one half of the question which is geometry, and the second half is some algebra. Or this kind of crossover questions are very common in mathematics, much more common than physics. Like in physics, if you remember, we had that one question about equivalent resistance and a specific heat. So that was like a one-off question. But most of the physics questions were like only of one topic at a time. But mathematics, you are going to find is the reverse. That most often the questions are combining multiple topics, and this is again something you don't have in school at all, right? In school, you have like one chapter on this topic, and you only get questions on that topic. So getting used to these multiple topics, like how to combine them, is very important. Okay. So yeah, we will see how to apply all of these things in the questions. Okay, so like another thing which you should keep in mind is that the questions themselves, if you notice, so these are the 20 questions from the two papers that we are going to discuss. And in the right, I've given the sort of this complexity column is like my rating of the difficulty. Like 1 star is easy, 2 star is medium, and 3 star is difficult. Or I would not say necessarily difficult also, but it will take more time to solve the. So if you look at it, one thing you notice immediately is that the complexity is kind of random. That there is no, in maybe in some other paper it would be going always from easy to medium to hard, but in this case, like for example this first paper, November 2023, right? The first two questions themselves, I would say, are relatively harder difficulty compared to the others. So what this means is that time management becomes very important. Like if you spend a lot of time, let's say 25% of the time you waste on just question 1 and question 2, and at the end also you may or may not get the question, then you are losing the opportunity to solve all these simple questions. So there is no fixed pattern also. The next paper, the order is again different. So you have to be prepared for this randomness. And to some extent, this is also trying to test that how quick you are to think along the way, that immediately are you able to switch your strategy. So balancing your time between all the questions is very important. I mean, I would say at least you should be able to give at least one attempt to every question. That it should not happen that you run out of time and the last three questions you could not read at all. Maybe they are the easiest questions, and that will give you the marks most quickly. So balancing your time is very important. If you are spending too much time on one question, quickly move, skip and go ahead, and come back to that question later. So so some strategy like that, like whatever works for you. So every student may have a different idea, but you use some clever tricks like that. And so actually what I'm going to do this time, so last time for the physics, the same thing which I had done, I was going topic wise. So in the same way here also I'm going to go topic wise. But again, one difference you'll notice compared to physics paper is that in the physics all the topics were almost, for the two papers, were almost of the same order, right? Like if question one is of kinematics, then the question one will be of kinematics for all the papers. But here it is much more random. So that is why we will have to jump around a little bit to keep stay within the same topic. But largely speaking, today I'm going to cover all the geometry questions first, and then next time we will look at the other non-geometry. It's mostly the algebra questions. Okay? So we'll try to divide it that way. Uh, Again, if you want to take a screenshot of this, you can do that. Okay. So before we start solving the questions, these are some important ideas which I think everybody should know very well. So let me just mention them briefly. We don't have time to discuss each of them in detail, but this must be already part of your school syllabus or textbook, so you can just go and read it from there. So obviously, so one important idea which keeps coming again and again is the idea of chasing length, ratio, and area. So this term chasing some quantity, which maybe is a new term which typically is not used in school. So I will explain what that means. But basically, the idea is when I say chasing length, it means that I'm given some distances and I use that to find another distance or another distance. So like that, from one length I get another length and another length. And the same can be done with ratios and areas also. So whenever you are, computing these quantities one after the other, that is typically called chasing the length ratio on area. And in the same way, you can chase angles also. Like if you have like parallel lines, you must be knowing some properties about the corresponding angles or alternate angles. Or, for example, in the circle, you have some properties about the inscribed angle, and so things like that. So different problems will require you to focus on different quantities. That in some questions the lengths are the important thing, in some cases the angles are important. So accordingly, which properties you should consider to apply, that sort of set of properties changes, right? And we'll see examples of this in the questions. But so let's say within the topic of chasing lengths, so what are the most important properties that you should know? So Pythagoras theorem, obviously. Uh, don't underestimate Pythagoras theorem. Like you can ask seemingly very difficult question on even Pythagoras theorem also. Midpoint theorem, I think you must be knowing this. Special shapes are very important. So, okay, so triangles of special angles, like when a 30, 60, 90 triangle, maybe must have already studied this in school, that the ratios of the sides are of a very specific nature. So suppose this is my 30, 60, 90 triangle. Okay, so then I this always helps me to remember this sort of template in my mind. Like it is like a stencil, right? Like if I have this length side of length 1, then as per the properties that you must be knowing already, you can compute that this side is of length root 3 and this side is of length 2. Okay, so keep this sort of photograph in your memory, that this is the shape of the triangle. Now the actual triangle may be of double the size or 4 times the size or whatever, but even if the triangle is larger, the ratios don't change, right? So suppose somebody has a 30, 60, 90 triangle, uh, that let's say that this length is given as 100, let's say. Then quickly in your mind, if you have this template in your memory, you can quickly apply it here and figure out what the other sides are going to be. That if this is 100, then this is going to be half of that, 50, and this is going to be 50 root 3. Okay, so what we are doing is keeping the ratios the same between this smaller triangle and bigger triangle. Okay, and the same thing you can do for the other triangle, like 45, 45, 90 triangle. Again, it is a very standard triangle. It is isosceles right angle triangle. So therefore, the ratios of the three sides are 1, 1, and root 2. And this 30, 30, 120 triangle is nothing but 30, 60, 90 triangle joined to itself. So if I imagine that I have a 30, 60, 90 triangle like this, and I make a sort of mirror image of that triangle like this. Okay, so imagine that this is like a mirror. Then I take a mirror image. Then this is also 30, right? And so this whole angle becomes 120. So this is a 30, 30, 120 triangle. And again, this has if this length is 1, this length is 1, then this whole length becomes root 3. Okay, so again, another important triangle. So again, I'll just wait for 1 minute if you want to copy, but basically these three shapes are very important. Okay, 30, 60, 90, 45, 45, 90, and 30, 30, 120. Okay, because many questions can be asked using these properties. Okay. So in the same way, other important shapes are quadrilaterals like square, rectangle, rhombus. Again, I will not go through all of these, but I assume that you must be knowing the formulae for finding the area, the perimeter, and all those things, and how to recognize them. Like, so what is the way to say that a given quadrilateral is a parallelogram? So there are several conditions, right? Like for example, the diagonals bisect each other, or the both the pairs of sides are parallel, or equal in length, and all those things. So keep those things in mind. For regular polygons, I mean, again, just knowing one important property, which is the angles, right? Like what is the angle at each vertex, the internal and external angle. So again, that formula is going to be important. Okay. Then distances between parallel lines or ratios between parallel lines. So this actually is based on the idea of basic proportionality theorem. That basically, if you have something like this, that suppose you have three parallel lines, and if you have any transversal like this, then the now in this case the three lines appear to be equidistant. So let me just change one of them. Like for example, let us say the lines are like this. Okay, and some transversal is like this. Then the segments that transversal cuts the line into, right? So the lengths of these segments are going to be in some fixed ratio. Let us say 1:k. Okay, so which means that the bottom segment is k times the top segment. So the important property is that this ratio 1:k remains fixed even if the transversal changes, right? Suppose you have some different line like this, which is also cutting these three lines. Then again, the length will change of these segments, but the ratio will still be 1:k. Okay. And so no matter how you cut these two parallel lines, always the two segments that you're going to get are going to be in the same ratio. Okay. So this is an important property. Uh, then some basic coordinate geometry you're supposed to know. So for example, the distance between 2 points, the distance formula, which I think you must have done in school. Uh, then the midpoint of 2 points, like if I have x1 y1 as one endpoint and x2 y2 as the second endpoint, then do you know the formula for the midpoint? That what is the coordinate of the midpoint? Anybody?
x1
x1
plus
plus
x2 by 2.
2.
Yeah, right. X1 plus x2 by 2. So basically, it's the average of the two, right? So basically, the point which is lying exactly in the middle will have the average of the x and y coordinate. And the same way, the centroid is the average of 3 points, right? So if I point A, B, and C, then the centroid will have the coordinate which is the average of all three of A, B, C. Okay? So knowing this is important. Okay. Similar triangles I already mentioned, so I will not talk about that again. Basic trigonometric ratio, like just knowing the definition of sine theta and cos theta. That is all that is you're related to know right now. That okay. In a triangle, right angle triangle, if I have angle theta, then then the sine theta is the opposite upon hypotenuse, and cos theta is adjacent upon hypotenuse. Okay. So again, I assume that you must be doing this in school already, so I'm not repeating it here. But just knowing that sine and cos is important. Okay. And then area formulae. So there is one very important property about triangles with a common base or a height. Okay. So let me just illustrate this quickly. So as we all know, what is the area of a triangle? It is half base into height, right? So if there are two triangles, okay, suppose let us take a situation where the two triangles have the common height. So there are two parallel lines, and this is triangle one, and some other point is here, and this is triangle. So the triangles are not congruent. They are just some two triangles such that these lines are parallel. And now if I write the area, let me label the points A, B, C, D. Okay. So the area of triangle ABC, and often we will use the square bracket notation, okay, for area. So area of triangle ABC is half into base. So let us take BC as the base into height. And so height is what? Height is the perpendicular, right? If I drop a perpendicular from here to the base, then this is the height. So this is the area of triangle ABC. And triangle DBC will also have a similar area, half into base into height. And so the important thing you notice is that the length of the height is the same, right, for both. Why? Because this line BC and AD are parallel. This is very important because now if I take the ratio, then do you see that on the RHS half will cancel, and so in fact everything is going to cancel, right? So it is going to be 1/1. So these two triangles have equal area. Okay. Suppose I have another triangle. So bad diagram. Okay. On this same parallel line, suppose I have some two different points, x, y, and z. Okay. And now if I write the area of triangle x, y, z, it is also into half into the base into the height. So again, height is h, right? Okay. So if I ask the question, what is the ratio of the areas, like ratio of ABC and XYZ? So now you'll observe that ABC was half into BC into H, and XYZ half is XY into H. So what is common? Half is common and H is common. So therefore, what after everything cancels, what is going to remain is just the base. Okay. So in other words, when the height is common, so this is the case when height is common. So therefore, the ratio of the base is the ratio of the area. Okay. So the ratio of the areas of the two triangles equals the ratio of the bases. And you can have a situation where instead of the height, the base is common. So base is common and heights may be different. So for example, that diagram may look something like this. That suppose you have triangle ABC over here, and on the same base BC there's one more point D. Let us say it is somewhere over here. Okay. And now again, to simplify my calculation, I'm just going to write the final formula. I hope you understood the logic. So the area of ABC and DBC, see, the ratio will be equal to the, now the base is common, right? So if I write the formula, half will cancel, BC will cancel, and only the height will remain, right? So if I drop the height from the 2 points, if I call the this height as H1 and this as H2, then this will be the ratio, that the triangle which is larger height will have more area, obviously, and the smaller height will have lesser area. So again, this is very obvious. All of this comes from just the formula of the triangle, like half base into height. But this can be applied in very sort of clever ways, to make seemingly difficult problems. Okay, so these are some important ideas in geometry that you should know. And in case you need to revise any of this from your school textbook, make sure to do that. In the same way, we can also come to algebra. So some important identities that everybody should know. So like for example, basic factorization and expansion of a plus b bracket square, a minus b bracket square. Same for cubes. Uh, and on all of them, there is a special case, like when one of the terms is the reciprocal of the other, like if b is 1 over a, then the expansion has some very particular form, right? So for example, a plus b bracket square, as we all know, is a square plus 2ab plus b square. And in this, now suppose if you choose b as 1 over a, right? So if b is the reciprocal of a, then what happens is the middle term, right? This a and 1 over a will cancel. So you will just get a term like this. Okay? And lots of questions can be easily created on this concept, like using the reciprocals in the bracket. In school you must have already done some examples like this, but we will see more examples in our problem. Okay. And some other identities like these expansions, I think you must be already knowing some of them. Uh, can you confirm if you know the expansion of these last two, like a plus b plus c bracket square and this one? Are you aware of these two terms?
Yes.
Okay. Okay. So yeah, I mean, in case you don't know that, you can easily Google this and find the answer. But or in fact, you can try it on your own also. It is not difficult. Okay. So, but yeah, knowing this identity is very important. Then some sequences, like some standard sequences are arithmetic progression, where the sequence keeps increasing with a constant difference, like this term d gets added every time. So what is the sum of this kind of a sequence? So that is typically you take the first and the last term and you take their average. Okay, and that is also the average of the entire series. Okay, and so therefore if you just multiply this with the number of terms, you are going to get the sum of the whole sequence. Okay, and in the same way, like triangular numbers are like 1 2 3. So 1 plus 2, 1 plus 2 plus 3. So these are called triangular numbers. Okay, if you add the first n number of natural numbers together, the answer that you get is called the triangular, and often it is denoted as Tn. Okay, so Tn stands for the nth triangular number. Okay, and the formula of that is, I mean, it's the same formula as what we did here, but just in if you substitute the values, you get this formula, n into n plus 1 upon 2. Again, I think you must be knowing this already. Then how to solve equations in one variable or multiple variables. A quadratic equations, you should know multiple ways to solve quadratic equation, not just one way. Like factorization by observing the roots, like observing the how the terms get factorized, completing the square, and using the b square minus 4ac formula. And then the last thing is the roots and coefficient. Like whenever you have a quadratic equation, right? For example, the first one. So if ax square plus bx plus c is equal to 0 is your quadratic equation, and the roots that you get are alpha and beta, then you what it means is that you can rewrite the quadratic equation as factorize it in this way, that you take the constant a outside, and inside the bracket you have x minus alpha and x minus beta. Okay, and then if you expand these brackets and regroup it, you are going to get, so for example, what is going to be the coefficient of x square? So x square is going to be ax square. Then what is going to be the coefficient of x raised to 1? So that is going to be minus a alpha plus beta to x. And finally, the constant term will be a alpha beta, right? If you expand this bracket. And now if you compare this formula with this formula, like term by term, right? You can see that the coefficients can be equated. So this a and a are matching. So there is nothing there. But what it means that this term has to be equal to b, and this term has to be equal to c. Okay. So if you rearrange that information, you get something like this. Okay. So basically, the sum of the roots. So alpha plus beta is the sum of the roots, and alpha beta is the product of the roots. So both of these can be related to the coefficients of your original quadratic equation. So like even without calculating the roots, you know the sum and the product just from the coefficient ABC. Okay, so again, maybe most of you know this already, but I want to emphasize this property. Okay. Yeah, so I mean, we spent a fair amount of time going through these basic ideas, but it is important to explain that why you should focus on all of these things, because each of them can be used to create seemingly clever problems. Okay, with that explanation done, I think we can start with actual problem solving. Any other questions about the theory part, geometry or algebra? Okay, if not, then let me go to the questions. So as
Sir,
I said,
sir, hello.
yes.
Sir, what is triangular number? Can you explain once again?
Okay, so the triangular numbers is nothing but a series of numbers such that, so the first term, so t1, the first triangular number is just 1. Okay, the second triangular number t2 is 1 plus 2, which means 3. The third triangular number is 1 plus 2 plus 3. So like that, basically you just keep adding the natural numbers 1 2 3 4 10, like that. So the nth triangular number tn is given by 1 plus 2 plus 3 up to n. Okay, so first thing you'll notice, this is just one more arithmetic progression, right? Because the each term is one more than the previous term, so the constant difference is 1, right? So if you want to find the formula for this, you can apply the same formula for what you did for arithmetic progression. So the sum of this is going to be the number of terms into the average of the sequence. Okay, and the average is nothing but the first and the last term upon 2. So therefore, if I just add the first and last term upon 2, so this is the sum of the first n number. Okay. Okay. So this is the formula for the nth triangular number. And the reason why they are called triangular numbers is because you can easily arrange these points in a triangle, right? Imagine that you are trying to stack objects like this. So like when you are three stacks is 1 plus 2 plus 3 6. 4 stacks is 10, like that. So you can arrange the points in a triangle. That is why it is called a triangular. So for example, this is a stack of length 5. So you see that there are total 15 balls in this stack. Okay. So we'll see that at
Okay,
least
okay.
2 or 3 questions which are using the concept of triangular number. Okay. So we'll see that at least 2 or 3 questions which are using the concept of triangular number. Okay. So we'll we'll see that at least 2 or 3 questions which are using the concept of triangular number. Okay. So we'll we'll see that at least 2 or 3 questions which are using the concept of triangular number.
Okay.
Okay. Okay. So let me start to solve the questions. Yeah. Any other doubts anybody may have, we'll resolve them along the way, right? When we do the topic. So this first question, right? Question 21. If you remember that table which I had drawn earlier or shown earlier, that I rated this question 21 as a very high complexity. Um, and the reason for that is not because this is something difficult. This is just going to be time consuming. Okay. So, and this is again the judgment that a good student should have, like somebody who is going to do well in an exam like this, quickly looking at the question and realizing that okay, this is going to be very time consuming, and lots of it's prone to errors, that even if you make one calculation mistake, your answer will happen to be wrong, and you will have wasted a lot of time. So only the student who are confident that they are going to do all the calculations correctly without any single mistake, they should spend sufficient time on this problem. But some other student may feel that I'm going to waste a lot of time doing calculations, let me come back to this question later on. Okay, so keep that in mind. But the question itself is, I think, very simple, because all you have to do is there are three lines given. So line AB, and let me rearrange that while writing it itself. So let me take the constant to the other side. Uh, line BC and line CA. Okay, so the equations of three lines are given, and so basically you see that the first two lines have point B common. So if I solve them like a simultaneous equation, I'm going to get the coordinate of point B. If I solve the second two equations, I'm going to get the coordinate of point C. And finally, if I solve the first and the third equation, I'm going to get the coordinate of point A. Okay. And so once I get these 3 points, then as we just discussed earlier, that the centroid is just going to be the average of the three coordinates. Okay. So you see, it's just a lot of calculation. Like three times you have to solve the simultaneous equation, and the numbers are also like some of them like 24 and 13. So doing it carefully can be critical. Okay. So let me just, like, for completion, let me just solve the first two equations. So I mean, this is standard theory. You must be already knowing this, that to solve the simultaneous equation, we have to eliminate one of the variables. Right? By the way, I accidentally wrote. Okay, so let's say we want to eliminate y. What I will do is multiply the first equation by 3 and second equation by 5 and add them together so that y will get cancelled. So what am I going to get? 39 plus 30, so that is 69x is equal to, on the RHS, it will be minus 3 minus 20. So therefore, x is minus 23 by 69 or minus 1 by 3. And once you get x, you can plug the value of x back in one of the equations. Let us say equation 2, and I'm going to get 3y is equal to minus 4 plus 2, right? So I got the equation coordinate of x and y. So this was point B, right? So because B is the common point for these. So therefore, the coordinate of point B I got was minus 1 by 3, comma, minus 2 by 3. Okay. So a very simple like simultaneous equation. And if you repeat the same process for the equations 2 and 3, I'm going to get the coordinate of C and A. So let me just write the answers. Like I think point C is uh, minus 3 by 2, and
Sir, why don't we use the formula for centroid of the triangle?
but to apply the formula, don't we need to know the coordinates of all the 3 points?
Oh, yes, sorry.
Correct. So what is given is the equation of the lines. Like so the lines of the triangles are known, but the points themselves we don't. So yeah, we are doing that only. We'll first find the coordinates of the 3 points, and then we'll apply that formula.
Yes, sorry.
Yeah. Okay. No problem. Okay. So I got the coordinates of all the 3 points. I'm just writing the answers over here because this is just a lot of calculation. Okay.
Sir,
Yes.
When I'm solving equations BC and AC, like to
Mm-hmm.
find C, I'm getting
Mm-hmm.
y as 100 by 115 by 16.
Can you tell me how you're solving?
So it's 6x plus 3y plus 4 and 2x plus 24 minus 37, right?
Yes.
Now, if I multiply AC by minus 3, the and add them, they cancel each x coordinate gets cancelled out, right?
Yes. Okay. So if I multiply this by minus 3 and add it to 2, yes, the x coordinate will get cancelled. Okay.
Yeah. So when you do that, you get
Hmm.
minus 69y plus 115 is 0.
Yes. Okay.
And that gives me y as 115 by 69 minus, sorry, 115 by 69, yes.
Yes. So isn't
And
that 5 by 3? Because 23 is common, right?
oh,
Yeah,
oh,
23 divides
okay.
both the, yeah, right? So you
Oh,
can
yeah,
remove
yeah,
them.
yeah.
Yeah.
I sorry. Oh God. Yes.
Yeah. But you see, so that is why I'm saying that this question is going to take up a lot of time to do these calculations. And in the end, even if you make one mistake, you might lose the mark. So I will advise only the students who are, very confident that, I make no silly mistakes. Only they should do this question at first attempt. Otherwise, always, you'll always come back to the question later on if you have time. But yeah. Okay, so once you get these points A, B, C, then finally getting the centroid is just, you take the average, right? So let me just jump to that part. So therefore the centroid will be, so the x coordinate of the centroid, and note, see the coordinate of the centroid is given as h comma k in the problem. So I need to, let us find h and k separately. So h will be the average of all the x coordinates, right? So the x coordinates or of ABC are half, minus 1 by 3 and minus 3 by 2. This is h, and k is the average of the y coordinates. So that is 3 by 2, uh, minus 2 by 3 and 5 by 3. Okay. So I mean, at this point you can be a little bit more efficient by, not finding the actual values, because finally they want the answer as integer. So what they have asked is 9h plus 6k, right? We don't need to know h and k actually. So I need to find 9 times h plus 6 times k. So that is going to help some things to cancel, right? Because when I multiply this thing by 9, then this 3 and 9 will cancel, and so some things get simplified that way. So I want to get 3 times inside the bracket, it will be, uh, minus 1 by 3, and half and minus 3 by 2 will become minus 1, plus when I multiply this by 6, the 3 and 6 will get cancelled, and again inside the bracket you will see that these two terms combine to plus 1, and so overall this is minus 1. So you see, after all this effort, the answer I'm going to get is just 0, 1. Okay. Yeah. So yeah, so this is how you solve the question like this. I took some shortcuts. I did not actually solve the full simultaneous equation, but I hope everybody is able to follow the method at least. Okay. When you start studying in your 11th and 12th standard, you will come to know some shortcuts, like to solve two simultaneous equations. This is the school method, right? Where multiply and eliminate one variable. There is a more efficient formula which is called Kramer's rule, which will save you some time, but honestly, it is still a lot of calculation. So if you want, you can Google this formula called Kramer's rule, and if you are feeling interested to apply that, that will save you some time. But ultimately, still, I will rate this problem as, uh, so this is where your time management is going to be important more than your mathematics knowledge. Your efficiency as a exam paper taker, paper solver, I don't want to call it. Okay. So yeah, use the competitive edge to go ahead. Okay, I'll go to the next question. So again, the next question is also of a very similar nature, but not so much calculation involved as such. But again, it is coordinate geometry. and applying the formula for the centroid and the midpoint. So some partial information is given. So in the triangle, some information is given. So the midpoint of BC is given, okay, and the midpoint of AC is given. And yeah, so all the three midpoints are given basically. Okay. Okay. And from that you have to find, so G is the centroid of triangle ABC, right? So if I, so centroid is the point where the medians are concurrent, right? Do you know any other properties about G? Have you studied this in school already?
They divide median and the ratio of 2:1.
Yes. Okay. So again, important property that the centroid divides the medians in the ratio 2:1. Okay. There are some other also interesting properties also, which I will mention after this problem is done. But right now, this is going to be very useful because what they have asked us to find is AG square, right? So if I know that AG upon GD is in the ratio 2:1, or if I write it in the what we can say like component derivative fashion, then AG upon the full median, right, will be 2/3. So if I find AD, then from that I can reach AG, right? So you see how I'm converting the given problem into a different problem. That to find the answer to this question, I have to solve a different question. So I need to first find AD. Okay. So how will I find AD? I know the points D, E, F. Anybody has any idea?
Yes, sir.
Yes, go ahead.
Sir, we know F is X. Okay, so let's say that A is X1, Y1, B is
Okay.
X2, Y2, and C is X3, Y3.
Okay.
So we have been given that F is -4, 4, right?
Mm-hmm.
Which means that X1 plus X2 by 2 is -4, which gives us X1 plus X2 is -8.
Yes, correct. So basically,
Similarly,
yeah, we'll get equations for all the coordinates, right?
yeah, and that and when you add them up, you get 2 times X1 plus X2 plus X3 equals 4.
Mm-hmm.
And
Okay.
that sorry, not 4, 6. Uh,
Okay.
and that gives us X1 plus X2 plus X3 by uh, what that gives us the coordinates of centroid, the X coordinate
Mm-hmm.
of centroid. Similarly, do it
Okay.
for the Y coordinate. Then you find GD
Yes.
and then multiply it by 2.
Yes. Yeah. 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 I think that's a good approach. So let me just explain. I was slightly faster approach, but I think what you explained is also valid. So for everybody, let me explain it once more. So basically, what we do is we know the midpoints of the three sides, right? So for every side, if I take the average of the two coordinates, so for example, for segment AB, the average of x and y coordinates, so x1 plus x2 by 2 is the this x coordinate -4. Okay, and similarly y1 plus y2 by 2 is 4. Okay, and like that, if I write the equations for all of them, right, and if I add all of them together, right, what is going to happen? See, x1 is going to come two times, once for this side AB and once for this side. So each term x1, x2, x3, all of them are going to occur twice. So and every time it is divided by 2, right? So if I add all of them together in the end, I'll have x1, x2, and x3, all of them occurring with exactly coefficient of 1. Okay. I hope you are following this. That every time, like if I add these three equations, then you see x1 was with a coefficient of half over here, and again with a coefficient of half over here. So therefore, total coefficient of x1 will become 1. Okay, and so therefore if I just add the x coordinates, right, of all the DEF, that is just going to give me x1 plus x2 plus x3. So that is 3, right? And similarly, y1 plus y2 plus y3 is just going to be the sum of the y coordinates. So 4, 3, and minus. Okay. And so from this, yeah, I don't, even if I don't calculate the coordinates of ABC, I know that G is the average of all three, right? So the coordinate of G is just going to be the x1 plus x2 plus x3 by 3, and and so that is 1, and the y coordinate will be y1 plus y2 plus y3 by 3. So you see, I found the coordinate of G as 1 comma 2 without even finding the positions of ABC. Okay, and then once you find G, then again, then on that median we know the length, so we can say that so then on the median we know that whatever is the length of GD, which you can find by distance formula. If I say that length is L, then you see AG will be twice of that, so AG will be 2L, and then that will give you the answer. Okay, so for completion, let me actually do the calculation. So G is 2, 1 comma 2, and D is 2 comma minus 1. Therefore GD square will be, by distance formula, it will be the 1 square plus 3 square, right? So which is 10. So GD square is 10. So therefore AG square will be so because AG is twice of GD, right? So the square will be 4 times. So the answer is 40. Okay. Any questions about this approach before I show you one more method? Okay. So there is one more way to look at this problem. And for that, let me focus, like, let me zoom in on the diagram a bit more, or maybe let me draw the diagram separately. Okay. So this is actually related to the fact that there are so many other properties also in this median configuration. So by the way, this word configuration is used very often in when talking about lots of related properties. Okay? So when this diagram has so many interesting properties all happening together, it is called a configuration. Okay? So let me point out some more interesting properties. The first is, of course, we have noted that all the medians are concurrent, and the ratio of the segment, like AG upon GD, and so all those ratios are equal to 2:1. Okay. Apart from that, see, because D is the midpoint of this side, right? If you go back to what we had done very early today, that we said that when two triangles have the common base and common height, then their areas are equal, right? So here, do you see that triangle ABD and triangle ADC have common base and height? Okay. So what do I mean by that? Like, what is the area of triangle ABD? It is half into the base, which is BD, into the height. So height is, if I draw this, that is the height, right? So this is the area of triangle ABD. And what about triangle ADC? That is half into the base BC into the height H. But do you see, because D is the midpoint, so the BD and BD are equal, and the height is also equal. So therefore, in fact, these two triangles have equal area. Okay, triangle ABD and ADC have equal area. And so basically what it means, that the median, like AD is the median, right? So the median is dividing the original triangle into two equal area triangles. Okay, so this triangle ABD and ADC have equal area. And in the same way, like, I will not go to the full proof over here, but you can further show that in fact all the 6 triangles you are getting here, all of them are equal area. So you see all of these small triangles that you are getting. So if I say the original, let us say the original triangle ABC has area denoted by capital this delta, then each of these small areas is exactly area of 1/6 of that. Okay, so all these 6 small triangles have all of them equal area of delta over 6. Okay. Uh, Furthermore, so this is all about areas. But what about the sides themselves? So use a different color. Beyond this, you know that D and F are midpoints of the two sides. So you must be knowing midpoint theorem. So what midpoint theorem says is that if I join DF, then DF is uh, half of the base and also parallel to the base, right? So DF and AC are parallel, and DF is half of the base. And if you notice, AE is also equal to half of AC. So in other words, this FD and AE are two equal and parallel sides. So they are parallel to each other and are equal in length. So when two sides are parallel and equal, what gets formed over here? The parallelogram gets formed, right? So this DEFA is a parallelogram, and you see in the diagram it looks like a parallelogram also. And when it's a parallelogram, one of the properties that parallelogram has is the diagonals bisect each other, right? So if I join the midpoint of EF, so this point, right? If I call it some different name, T. So T is the midpoint of EF as well as AD. Okay, and why was this possible? Because this AEDF, I forgot to mention that AEDF is a parallelogram. Okay, so all of these properties are there in this diagram. Actually, I have not even finished showing all the properties, but you see that so many things are happening. So by the way, this there is nothing special about AEDF. In the same way, this, like, I'm using a different color to mark this, BEDF is also parallelogram, and there are not of colors. This is also a parallelogram. So there are so many parallelograms and everything happening in the same diagram. Okay. So when you have so much information, becomes difficult that what should I use first, what should I use next, becomes very difficult to figure out. Yes, further.
Sir, I have a doubt in this question.
Yes, go ahead.
Sir, so yeah, when we calculate the the centroid of triangle as 1 comma 4
1 comma 2.
and 1 comma 2 and we have D as 2 comma minus 1.
Yes.
So we can find A.
Yes.
So
We can find the coordinate of A, but we don't need to find the coordinate of, because we just want the length of AG.
oh, and if we calculate and then distance of AG and its square, is it a correct method?
Yes, it is correct. Why not? But how are you going to calculate A from G and D?
If we calculate G and D, we have the ratio 2:1.
Mm-hmm.
So we can use that formula x is equal to m1 x2 plus m2 x1 upon m1 plus m2.
Oh, yeah, okay. So section formula, right? But keep in mind that the A is outside the length GD. So if you just take 2:1, like, you have to be careful how you apply section formula. You
Yes.
must be aware of section formula when the point, like, if I have 3 points A, P, B, and P is between A and B, then there is one section formula. But if the
Yes.
point P goes outside segment AB, then some of the signs have become from positive to negative. So you have to be a little
Yes.
bit more careful. But yes, your
Yes,
method
sir.
is correct. Yes, we
Yeah.
can use.
Yes.
Yeah. Okay. So this point T, which is a midpoint of EF and AD also, this is going to be helpful for us. So for example, let me just write my solution over here. Okay, so my observation is that parallelogram AEDF. Okay, so basically what I'm going to say, the midpoint of EF is the same as the midpoint of AD. That is what I want to use here. So that will give me a way to calculate find point A directly, right? Because midpoint of EF I can find because I have E and F. So what is the midpoint of EF? It is just the average of these two coordinates, right? So that is 5 minus 4 by 2 and say 3 plus 4 by 2. Okay, so the midpoint of EF is simply half comma 7 by 2. And this is also equal to the midpoint of AD. So AD is, so the x coordinate will be x1 plus 2 by 2 and y1 minus 1 by 2, right? So this is the midpoint of AD. So if I equate them, you see I'm going to get the coordinate of A directly, right? So I'm going to get half is equal to x1 plus 2 by 2 and 7 by 2 is equal to y1. Okay. So if I solve them, I'm going to get the values of x1 and y1 directly. Yeah. Okay, and then from here you can proceed the same as before. So finding the point A, and now so you know A, you know D, so I can find AD square, and from AD square I can find AG square. Okay, so I will not repeat the calculations there, but you see there are so many different and interesting ways to solve the same question. Okay, so with more experience you will start to see all of these proper possibilities, but as a homework I'll suggest to you that spend more time with this median configuration and find all the interesting properties, many properties which I have not even mentioned right now because of time, but yeah, you should explore all of these possibilities. Okay, anything else about this question? Yeah. So these were the two coordinate geometry based questions, so I wanted to finish them first. Then let's go to the next question 24. Okay, so given a regular hexagon. Okay, so the point P is given and some information is given. So you see the side of the hexagon is not given, but the question is saying find the area of the hexagon. So if I find the length of the side, so let me call that unknown length as x. Okay, so this is the length of the side of the hexagon. If I find that, then I can find the area. Then what is given is PBC is 5 and PAD is 6. Okay, so how can we solve this problem? So first thing you'll notice is that both these triangles, like PBC and PAD, what do you observe that they have their base is x, right, in both cases. So if I write them as half base into height, so there the x will going to be there in both the terms. But in addition, you are also going to have this like altitude, right? If I drop this altitude, then we'll have to some. So let us give some names, like let this called be h1 and h2. Okay, so I'm going to get the first area of PBC is 5 is equal to half into the side length, the base BC into H2, and PAD is half into again the base into H1. Okay, so now if I add them together, what I'm going to get is 11 is equal to half into X into H1 plus H2. Okay, so now it may seem that what is the point of this H1 plus H2? Like I don't see how to use that information in any way. That how can I try to apply H1 plus H2?
Sir,
Mm-hmm.
the place where you have marked D, shouldn't there be F? D should be below C, right?
Oh, sorry. Yeah, okay, I might have
Yes,
taken it.
yes.
Okay, sorry. Then I'll need to do this question again. Wait. Oh, sorry. Okay, let me start the labeling from here then. A, B, C, D. Yeah, even I was wondering because I solved this question before, but this diagram looked very alien to me. Yeah, okay, that makes sense. Okay, so now P is over here. So what is beyond this? PBC and PAD. Okay, so area of PBC. Okay, so the again, if I say the length of my hexagon is X, then the first thing is that AD. If you notice, so one property of regular hexagon is that if I take the central point and I join it to all these sides, then you get all these equilateral triangles, right? So therefore, basically what we can say is that this length of AD is just 2x, right? AD will be 2 times the side length. Okay, and that will be useful for me because here, so again, if I write this as half into base into height, so here the base is of length x and height is this h1, and this is half into, now this time the base is 2x and the height is h2. Okay, and so the thing is I don't know the values of h1 and h2, but so what is a useful property about a point between two parallel lines, right? Let me just talk about that briefly, that when you have two parallel lines and you take any point between the two lines, and then if I drop altitudes like this, right, h1 and h2 from this point P, then you see the sum of the altitudes h1 plus h2 is nothing but the distance between the lines. Okay, so whatever is the vertical distance between the lines, if I call that as capital H, then that is what this h1 plus h2 is going to be. So even if wherever this point P moves, like if it moves closer to one of the lines, the other distance will increase and vice versa. But the sum will always going to remain constant. So we don't know the exact position of the point P, but I can still use h1 plus h2 to refer to this total height, right? So if I call this total height as h, right, then h1 plus h2 will be this h. And now here you see that the first time I was saying very earlier that the 30, 60, 90 triangles are going to be important. So do you see here that we are getting a 30, 60, 90 triangle? Like if I call this point T, then this triangle ABT is a 30, 60, 90 triangle. Okay, with one side as, so the side opposite 60 degrees is h, and this the hypotenuse is x. So therefore we know the ratio between these two, right? So I can say h has to be root 3 upon 2 times x. Okay, from this, and this h is nothing but h1 plus h2. Okay, so therefore if I combine these two equations in such a way that I get h1 plus h2 again, then I can use this information. So if I add them directly, it will not work because the coefficients are different, right? Here it is half, and it is here is half into 2. So here it is 1. So I need to first bring them to the same level. So if I take the equation 1 and equation 2, and let's say, so equation 1 I can write it as follows. If I take 2 to the other side, it is 10 equal to x into h1, and equation 2 is the half will cancel h2. Okay, so now the coefficients are equal so that I can add them together. Okay, and now here h1 plus h2 can be replaced by this quantity. Okay, so therefore now I am able to find the value of x. Okay, so I actually x square is also convenient to me because I want to find the area of the hexagon. I don't need to know the value of x, right? And so how to find the area of the hexagon? As I said, that it is a combination of 6 equilateral triangles, right? So each equilateral triangle of length x, you must be already knowing the formula for equilateral triangle area. It is root 3 upon 4 into the side square, right? So the area of one triangle is root 3 upon 4 into x square. So therefore, the area of the whole hexagon will be 6 times that, right? And I can just substitute this value over here. And so I'm going to get the answer as 48. So I think my answer is 48, but the official answer I'm seeing is 24. I think there
Yes.
must be calculation mistake. My answer is, anybody can confirm that your answer is also 48? Maybe I think the official question may have some mistake. Okay, but anyway, the final answer is not so important, but the method is what should matter. So again, the main idea here was this triangle PBC and PAD can be combined in such a way to get the H1 and H2 together, right? So this H1 and H2 have to be combined to get the total length H1 plus H2, which is the height of like in this 36 and 90 triangle. We know how much it is in relation to the hypotenuse. So you see lots of variables were involved, but finally they come together very nicely to give us this answer. And you see, till at the end, we don't know the values of H1 and H2, we still don't know, but we don't need to know that. Yes, Amruta.
Sir, how can the triangle ABT 30, 60, 90?
It is 3069. So BT is a altitude. So therefore, this angle is 90 degree because of that. And here, this, as I said, if I divide this triangle into these like 6 equilateral triangles, then you see that this angle is 60 degrees. AB,
Yes, sir.
BA, if I send called central point O, then BAO is 60 degrees.
Yes, sir.
Okay. Okay. So in case you did not know this property, that a regular hexagon can be very nicely divided into these 6 equilateral triangles. Okay. Any other question about this one? Okay.
Sir,
So again,
how
you're
the
seeing the, yes, go
sir,
ahead.
how the h is equal to root 3 by 2 into x?
Uh, this one.
Yes.
So that is because of this 30, 60, 90 triangle. In this triangle ABT, right, which are drawn to one side. What is the property of 30, 60, 90 triangle? The side opposite the 60 degrees is root 3 upon 2 times the hypotenuse. And the side opposite the 30 degree is half of the hypotenuse.
Yes, sir.
Yes. Okay. Okay, we'll go to the next question. Okay, again based on area. So you see how Yes, Harish.
सर आन्सर 24 यायला पाहिजे ना?
माझं आन्सर 48 येत आहे.
सर मी पण
ऑफिशियल
मी तुम्हाला करून फोटो टाकू का?
नाही, ऑफिशियल आन्सर की मला 24 आहे, मला पण माहिती आहे, पण माझं आन्सर 48 येत आहे. म्हणून म्हटलं तुम्ही पण चेक करा की तुमचं कॅल्क्युलेशन काय येतंय. माझ्या त्या आन्सर की मध्ये चूक आहे.
सर माझं 24 आलेलं आहे.
आलंय का 24?
हा.
थांबा, माझं कॅल्क्युलेशन मी परत एकदा चेक करतो. कॅन समबडी एल्स कन्फर्म यू आर गेटिंग आन्सर 24 or 48? Okay, so let me go through the steps one by one. Okay. So the first is this is 5. So from this I got this. The second equation is this. So when I add them, I get 16 is equal to this much. And here h1 plus h2 is replaced by root 3 by 2x. Okay, so therefore x square is 16 into 2 by root 3. इथपर्यंत तर बरोबर आहे सगळं. Then the area of one triangle is root 3 upon 4 times x square. So area of 6 triangle is 6 times of that. आणि मग इथे that is 6 into root 3 by 4 into this quantity. आणि त्याच्यामध्ये root 3 cancel झाला. 2 cancel झाला. माझं तर 48च येत आहे. So can you check your calculation?
48 आहे सर.
48 आहे ना? Just check your calculation. If you're getting 24, कुठेतरी एक 2 चा फॅक्टर चुकला असेल.
हो सर.
Okay, the next question. But you see how basic ideas are used to create these problems. हे सगळं तुम्ही शाळेत केलेलं आहे. एरिया ऑफ ट्रायंगल सगळ्यांना माहिती आहे. 30, 60, 90 ट्रायंगल सगळ्यांना माहिती आहे. But how to use all of that to create a harder problem. So that is the difficult part about this exam, not the theory. Okay, question 23. Okay, I'll just give you 1 minute to read the question because I'm not going in order. So maybe even if you have seen the question before, you may need some time to recall it in your memory. Okay, so parallelogram is given. Point E is on side AB such that AE upon EB, something like this, roughly speaking. And point P is on segment EC. So what is given is area of triangle EPB is 1/4 of the area of the entire quadrilateral, and CPB is given as 7. Okay, and find K. So K is the area of the entire quadrilateral. Okay, so this is again an example of where if I remember, I initially had used the term area chasing or ratio chasing. So this is a very typical example of that the multiple area or ratios are given, and so you have to use them together. So multiple times that concept, that common base or common height, you have to observe and try to use that in some. So if you observe, first thing is that let us consider if I take this diagonal AC, right? So it is going to divide my parallelogram into two equal parts, right? So triangle ABC will have the half of the area of the full ABCD. So ABC is K by 2. Then this ratio is given as 1 is to 2, AE upon EB. So if this ratio is 1 is to 2, can we say that the area, so AE upon EB will be equal to the areas or the ratio of the corresponding triangle. So triangle AEC and triangle EBC. Okay, why? Because again, same concept, half. If I look at this, these are the two bases or these two triangles, right? And the height is common. If I draw the height over here, the height is common. So when you write the half base into height formula, everything will cancel and only the bases will remain. So therefore, this is the ratio of the two bases. And then, so if this total area of ABC, which is k by 2, is split into the ratio 1 is to 2, right? So if ABC is k by 2, then how much will be the each part? So when you split k by 2 in ratio 1 is to 2, so imagine that this is a object of length k by 2. And if you divide it into 3 equal parts, so each part will be 1/3 of that, right? K by 6, k by 6, k by 6, right? And out of that, if I take 2/3, right, then that will be 2k by 6. Okay. So that is what we are doing to the area. That this total area of ABC, we are splitting into 2/3 to get EBC, right? So in other words, EBC will be 2/3 of ABC. Okay. So you see how starting from ABCD, we first got ABC. From ABC, we got EBC. And then, and finally, now we have all the information in one place. We only focus on this triangle and ignore everything else. So in this, what is happening? This part is 7. And EPB बद्दल काय दिलंय? EPB is 1/4 of ABCD, which is k by 4. So this part is k by 4. So I can now write the equation, right? EBC, this k by 3 is equal to 7 plus k by 4. And I have to solve for k. So if I just multiply by 12, you get k is 84. Okay. So what we applied here, the only sort of critical step was applying this ratio formula, that the ratio of the bases is the ratio of the areas of the triangle. After that, everything else was simple. Yes, Prasanna?
Sir, how did we find out that ABC is area of ABC is 2 by 3 of area of A by ABC?
Okay, so this step. No? So again, what is happening if you forget? Let us just look at this part. Okay, मी तो तेवढाच diagram इथे काढतो. Okay. So this is the base AB, ज्याला आपण 1:3 and 2:3 मध्ये डिवाइड केलं. So याच्यामध्ये AB is 2/3 of AB, बरोबर? So याच्यामध्ये what is the area of triangle EBC? So area of triangle EBC is half into base and ABC is half into, so ABC चा base AB आहे, and so ह्याचा मी रेशो जेव्हा घेतो BC upon ABC, so the ratio of the areas will be equal to, so you see half is going to get cancelled and H is also get cancelled, so I will only have EB upon AB. And when this is divided in the ratio 1 is to 2, then EB upon AB is 2 upon 3, बरोबर? So from this we are getting this.
Okay, sir.
Okay. So pay close attention to whenever you have this configuration. Okay, it should become fit in your mind की जेव्हा असे ट्रायंगल कधी पण दिसले की अशा टाईपचे की सेम बेस आहे, म्हणजे वरचा व्हर्टेक्स कॉमन आहे आणि खालची सेम लाईन आहे, देन ऑटोमॅटिकली युअर थॉट शुड गो टू दिस डायरेक्शन की ह्याचे द रेशिओ ऑफ द बेसिस are going to be equal to the ratio of the area, and then somehow applying that. This is a very common thing, so repeatedly तुम्हाला ते वापरायला लागेल कुठे कुठे.
Sir,
Yes.
in here the last step that you have taken that k by 3 is equal to 7 plus k by 4.
Mhm,
So how
mhm.
it had come?
So we are just looking at triangle EBC ना. So EBC मध्ये काय काय इन्फॉर्मेशन दिली आहे? This part is 7 हे दिलेलं आहे. आणि this part EPB is k/4 हे पण दिलेलं आहे. आणि द एंटायर EBC चा एरिया पण आत्ताच काढला k/3. So the entire EBC is equal to the sum of the parts.
Yeah, yes. Thank you.
Yes. Okay. Yes, Prasanna.
सर अशा क्वेश्चनला एकच मेथड असते का दुसऱ्या मेथडनी करता येतं?
फारसं काही व्हेरिएशन नाही आहे पॉसिबल. म्हणजे बेसिक कॉन्सेप्ट जी का हा जो पॉइंट ई दिलाय ना त्याचा जो रेशो वापरणं ह्याला काही दुसरा ऑप्शन नाहीये.
ओके
मला ऍटलीस्ट या क्वेश्चनला तरी मला काही दुसरी मेथड नाही सुचते. त्यावेळी दुसरा कुठला क्वेश्चन असेल तर बघूया. पण म्हणजे ही रेशोची कॉन्सेप्ट वापरायला काही ऑल्टरनेटिव्ह नाही. Okay. Okay, then let's go to the next question. Again, based on the same ratio area concept. Yes, Harish.
सर मी एक फोटो टाकलोय ग्रुपवर, त्यामध्ये माझं काही चुकलं तर सांगा की एकदा.
बरं, एक मिनिट. मी आपला क्लास झाल्यानंतर सांगतो. ठीक आहे.
हो सर.
तो आधीच्या क्वेश्चनचं सॉल्व्ह करून पाठवलं का?
हा सर.
ठीक आहे, ठीक आहे. बघ, माझ्या ते काहीतरी कॅल्क्युलेशन मिस्टेक असेल कदाचित.
बरं.
Okay. So question 29, again same ratio concept. So again give you a chance to practice this idea if you have any doubts how to apply it. So I will just wait for 1 minute. तोवर तुझा आन्सर बघतो. अरे तू त्याच्यामध्ये एबीसीडीचा एरिया काढलाय पण आपल्याला तर हेक्सागॉनचा एरिया काढायचा.
काय सर?
You have found the area of quadrilateral ABCD, but the question is asking find the area of the whole hexagon. मग त्याच्याबरोबर डबल नाही काय ना?
हा हा, येस सर, येस सर.
हा, ठीक आहे. Okay, so coming back to this question, PQRS is given. Okay, so it is a square, and inside that square is an equilateral triangle. So immediately when you have the question like this, where all the nice objects are given, like square and equilateral, they are all regular objects, right? All the sides are equal, all the lengths are equal. So there is a मागच्या वेळी फिजिक्स मध्ये एक क्वेश्चन केला होता. इट वॉज अबाउट रेजिस्टन्सेस. असा ट्रायंगल शेप होता. देन वी हॅड यूज द वर्ड सिमेट्री. Okay, this word symmetry is going to keep coming back in various places. When the situation looks very nice, balanced, then you can take advantage of that and make some simplifications. इकडे पण काय होणार आहे, डोळ्याला दिसतंय साधारण की पीए अँड बीआर आर गोइंग टू बी इक्वल. ओके, whatever is the length over here, हे पीए आणि बीआर ते इक्वलच असणार आहे. असं नाही, बिकॉज कॅन इट हॅपन की द ट्रायंगल इज असं आहे की एका साईडला कमी आहे डिस्टन्स आणि एका साईडला खूप जास्त आहे. असा ट्रायंगल होणं पॉसिबल नाही, एस्पेशली वेन इट्स इन इक्विलेटरल ट्रायंगल, राईट? Any other shape triangle, obviously it is possible, but when the inside triangle is also equilateral, then very likely this PA and B are going to be of equal length. Okay, so as a guess, I'm not saying that we have proved it, but this is a very reasonable guess. PA and BR are going to be of equal length, and then we can try to see if we can prove that or apply that. Okay, so can somebody see the reason? Can you prove this why PA and BR have to be equal?
So triangle PAS and SBR are congruent.
They are congruent, right? They are congruent by which test?
S, A, and S. No, S. Yeah. PS is equal to SR, And 90
BS
degrees
is
equal and AS is equal to BS.
RHS.
yes, RHS, right? Yes. So two sides are equal and one angle is equal, but the angle which is equal is not between, it's not an included angle. But luckily, because that angle is 90 degrees, so therefore RHS test can be applied. Okay. So therefore the triangles are congruent. Okay. And so that will help us because now what आपल्याला काय काढायचंय, we have to find the ratio of the ABQ to APS. बरं, ठीक आहे. So let us do one thing. Let us give the okay. And one more thing which we are going to do now is that we are not given the length of any distance. आपल्याला कुठलाच length दिलेला नाही. So I am just going to say let the length of my square be 1. Now your question is that how will I assume that I'm not given that maybe my square is of larger or smaller dimension. But because the whole question is about ratios, right? See, what is the question asking? It is just asking ratio of what we are supposed to find. Lambda is the ratio of APQ, ABQ upon APS. So if it is a ratio, how does it matter whether this length is really 1 or if it is something else? I'll just call this as 1. Like suppose the real square was smaller, then I can just expand that and to get this. In that process, the ratio does not change, right? So therefore, whenever ratio is involved, we can make this assumption that let some one length be 1. Okay. So that will simplify my calculation because now what will happen? And we already saw that these are equal. So this PA and BR are equal. So let PA and BR be X. Okay. And then let so this remaining, right? B AQ and BQ. So you could either call them as Y, but now because this total length is 1, so I can just call it as 1 minus X, right? The total square ची length जर का 1 है and त्यातला हा X आहे, तर this is just going to be 1 minus X. So you see how one variable is removed. If I did not make this assumption, then I'll have to have two variables, X and Y in my calculation. But now I can have everything in terms of X only. So that is the advantage of simplification. आणि आता आपल्याला काढायचं काय रेशो एरिया ऑफ ट्रायंगल एबीक्यू हा वरचा ट्रायंगल एबीक्यू त्याचा व्हॉट इज द एरिया ऑफ दॅट ट्रायंगल गोइंग टू बी AQ into BQ, like half into the product of the two sides, right? And APS is this triangle. So that's the one x side the one. Okay, so we want to find the ratio of these two quantities. Okay. And what else can we use here? Because this आतला triangle equilateral आहे, त्यावर वापरलंच नाही आपण. So if it is equilateral, then this AB and AS are of equal length. So if I write Pythagoras theorem for both triangles, right? So AB is the hypotenuse of triangle ABQ, right? So therefore AB square is and that will also be equal to AS square, right? And AS is the hypotenuse of this triangle. Okay, so these two lengths are equal. Okay, and you see from this formula we can go to this. आपल्याला finally शोधून काय काढायचं हा lambda ना. So the lambda was equal to the ratio of these two areas. So half will cancel. So I'm going to get 1 minus x square upon x. So I am interested in this quantity 1 minus x square upon x. Okay. So if I am able to reach that somehow from this information, then तेच आपल्याला हवंय बरोबर. तर ते आता कसं करता येईल? So if I expand this, right, what I'm going to get 2 minus 4x plus x square. Okay, I'm going to get this. And now, sorry, 2x square. Okay, so now you see that some terms are going to get cancelled here. So I'm going to get 1 minus 4x. Okay, so now here I can do two things. I can, if I want, I can solve and get the value of x. But keep your focus on where I want to reach. I want to reach this term 1 minus x square upon x. So do you see here I'm ऑलरेडी हॅव्हिंग 1 मायनस एक्स स्क्वेअर इकडे आहेच इकडे तर 1 मायनस 2x प्लस एक्स स्क्वेअर असं लिहू शकतो ह्याला मी सो आय एम जस्ट स्प्लिटिंग दॅस मायनस 4x एस मायनस 2x मायनस 2x ओके त्याच्यामुळे काय झालं की इकडे आय गॉट दिस न्यूमरेटर ऑटोमॅटिकली अँड हिअर आय एम गेटिंग द डिनॉमिनेटर so I have everything in place to just rearrange and get the answer. So can I directly rearrange this as 1 minus x square is equal to 2 times x, or in other words this ratio is 2, and that was exactly the lambda which is given or what we wanted to find. Actually remember, note the question is asking lambda square, so again don't hastily write 2 as the answer, but write the answer as lambda square, which is 0.4. Okay, let me repeat the calculations quickly. So first thing is that we quickly showed with congruent triangles that this BR and PA are equal. त्याला आपण x म्हटलं. And then we said the total length of my square is 1. So therefore the remaining part became 1 minus x, right? This AQ and BQ. Then the ratio which wanted to find lambda, which is these two areas. So we can write them as area formulae and cancel terms to get this. This is what we want to find. And then again, very initially what I had said, use all the information. So आतला triangle equilateral हे विसरू नका. So you want to use that this is equilateral by equating the area, the length of AB and AS. You see, so how we are using all the information. See, equilateral means all three sides are equal, right? So first part, that these two sides are equal, we use to show the congruence. So that part was already done. So there, that is just using the isosceles part, not the equilateral part. But now this is the second part where the third side is also involved, that we compare AB and AS. So now we have really used all the given information. Okay, and then the simplifying and with some regrouping, we directly get the answer that we want. Okay, this is one method. I think even if you don't use this trick of setting one side as x or one side as 1, you can still do the same problem. Like somebody did not realize that you can
Sir,
still do it in terms of x and y, you will get the same answer. Yes.
sir, I did
Yes.
this using a different method.
Yes. Okay.
Sir, let's say that the side of the equilateral triangle is A.
Okay, so let the side be A. Okay.
And it is we know that triangle APS and BSR are congruent, right?
Yes.
That implies that triangle QAB is isosceles and one angle is
Yes.
90, right?
Yes. Correct.
Which means that the so I use trigonometry in this.
Okay.
Say the side is, so the side of the equilateral triangle is A, therefore AQ is just A sine 45 and QB is A sine 45, right?
Yes.
Therefore, the area of triangle AQB can be written as area of triangle
yes, correct.
AQB can be written as sine 45 multiplied by cos 45 by 2.
Yeah, and
Now,
sine 45 and
in
cos
triangle
45 are just
APS,
1 by root 2, right?
yeah, 1 by root 2, yes. And
Yeah,
then
okay.
triangle APS and BRS, if we see angles PAS, SAR and SAR and BAQ form a linear pair, right?
Yes, correct.
So 45, 60, and the third angle will be 75. And one angle is 90, so the other angle will be 15.
Yes, correct.
So we know that sine 30 is 1/2 and cos 30 is √3/2. Using that, we can
Yes,
find cos 15 and sine 15.
yes. So using
So
the
we get
half angle
triangle,
formula,
sorry,
right?
the area of, yeah, half angle
Yes.
formula. And
Okay.
therefore, the area of triangle APS
Mm-hmm.
will be a square sine 15 multiplied by cos 15 by 2.
Yes, correct.
So if you find the values of sine 15 and cos 15, you get them as
Mm-hmm.
the square root of 2 minus √3 by 2 and 2 plus √3 by 2. You input that over here and you get the area of triangle APS as a square by 8.
Mm-hmm. Okay.
And similarly, triangle AQS as a square by 4. And you find the ratio, you get 2 and square it, you get 4.
Mm-hmm. Okay. Okay. Yeah, I think this is a fine method. I think the only problem I would say is that, I mean, not a problem, but I mean, at the 10 standard level, people typically don't know the half angle formula. So that is where maybe it will be
Sir,
a
it's
bit
given
difficult to
in
write.
the old edition of our textbook. So, and
Oh,
I
really? But
have that luckily. So,
interesting. Do they prove the formula or they just give it?
no, they just gave it.
Okay, okay, I see. Interesting. So, by the way, which board is this? Is it SSC or CBSE?
CBSE.
CBSE. Okay, interesting. So, okay, looks like in CBSE they give this half angle formula. Anyway, everybody, in
They
case you
used to
don't
give
know,
it before 2019, sir. Like after NEP, they removed it. So,
I see. I see. Interesting. Okay, but okay, for everybody, I will suggest not to bother with this because you are going to learn this definitely in your 11th and 12th standard. But yes,
Sir,
if you know the value of sine 30, you can find the half of that using this method.
sir, by using two variable, it is more easier.
Yeah, it is
As
possible to do with two variable also. Yeah, there is no problem. So yeah,
yes,
if you, I think, yeah, I agree. It is not that probably that is easier also. I also agree. Correct.
yes.
But in general, sometimes this method, so that is why I mentioned it. Sometimes it is useful to set one length as one to reduce your variable count. Yeah, so it is up to you whether you want to eliminate that y or you want to keep the y. Okay, any other comments? Okay, so I think these are all the problems which we were using the area concept and in various ways. Of course, same as physics and chemistry, I will also give you a practice paper where you have at least one or two more problems of this type to try out. But otherwise, mostly I hope that this much practice is sufficient. Okay, then let's go to a few questions which are more heavily based on trigonometry. So starting with question 26. Again, only thing that you need to know is the sine and cosine definitions. Nothing more than that is expected at this level. And of course, sine square theta plus cos square theta equal to 1. But yeah, that is the only expectation. So in this question, what is given is cos A and cos B is given. Cos A is 2/3, so maybe something like this. And cos B is 1/9, which is very small. Okay, so what is given is the okay. So the first question that you may have is that you want to apply trigonometry, but for that you require a right angle triangle. And in this diagram, there is no right angle given. So what you should do, so you can construct a right angle triangle, right? Like drop a suitable altitude. So for example, here, because the information about A and B are given, so naturally if I draw the altitude from C, it will create the right angle triangle for both the angles. in a single construction. So that is why that is a natural choice. So let that point at the base be D. Okay. Then now if you start to interpret the information, so first if you look at triangle BCD, okay, I know cos of angle B, which is adjacent side upon hypotenuse, so BD upon BC, which is given as 1 by 9. And I know BC is 24. So from this, I can find the length of BD. So BD. Okay, so I find BD, and I can find CD also. So you can find CD by Pythagoras theorem, right? Or I mean, you from cosine you get the sine, and then you apply sine ratio. Either way, it is the same thing. Okay, so CD will be root, or CD square will be 24 square minus BD square, right? Okay, and then what will happen? You come to the other triangle. So triangle ACD. Again, I can take the angle A, which is given, cos of A is given. And so if I apply the formula sine square A plus cos square A, okay. So when you know the cosine of an angle, you automatically know the sine and vice versa. Okay. And why is it important to find the sine of A? Because see, we are going to use this CD as the connecting bridge between these two triangles, right? I need something common to transfer the information from first triangle to the other triangle. And here that CD is going to be that bridge. And so if I want to use CD, then I need to know the sine of A, right? The cosine will be not be useful. So therefore, I found the sine of A. So sine square is this much. So sine of A is the square root of that. Okay. And so now in the triangle ACD, if I write sine of A, which is this is going to be the opposite side upon the hypotenuse. And so therefore, now I have everything to find AC. So AC is going to be just equal to CD into 3 upon root 5. And now I just have to substitute CD from here. But before that, so I was avoiding to simplify CD square, but we have to do it now. Okay, so this is CD square. And so therefore CD will be square root of that. Okay, I think see, because here in the denominator there is 5, so I expect that if I take 5 common, then I'll be left with a perfect square. So yeah, I think that is true, right? 1024, which is 32 square. So this is root 5 into 32 upon 3. So if I put this value of CD over here, I'm going to get AC is equal to root 5 into 32 upon 3. Okay. And so everything cancels and I get the value of AC as 32. So I think this is a fairly straightforward trigonometry question. All we had to do was apply trigonometric ratios in the two triangles, BCD and ACD, and just use the small trick to convert cosine into sine whenever required. But you see, that is just a small technical. Just like sometimes the question may fool you by giving meters instead of centimeters, but really meters and centimeters are equivalent, right? They are both length units. So in the same way, cosine of A and sine of A are not really different quantities, like in terms of information that they are providing to you.
Sir, please give me 2 minutes to note down this.
Okay, sure, please. Okay, but again, focus on the strategy, not the calculation. That first, what did we find? After that, what did we find? Because everybody knows Pythagoras theorem, everybody knows the algebra part of it. The again the order in which we calculated the things. That we started from BC, which was given. From that, we found BD and CD using the first triangle, and then from CD we found AC. So we went in that order. And the thing was, originally the question did not have that CD at all, right? The question only gave triangle ABC. So again, your understanding of trigonometry, that I need a equilateral triangle, so don't be afraid to construct the equilateral triangle wherever required. Okay. Any other comments about this question? Okay. Meanwhile, maybe all of you can start to think about the next question also. Again, using some very basic trigonometric ideas only, nothing more complicated. Okay. So going to the next question. So again, in this, if you just look at the diagram, again it is clear that cos of angle ACB is given, and there is no right angle. So again, we have to construct the right angle somewhere, and so the I think that this question can be done in multiple ways depending on how you want to do it, because the right angle has to be opposite angle C, but there is a choice there, right? You can construct the right angle on about any of the two sides. So basically, in this triangle, what is given is cos of angle ACB. Uh, what else is given? BC is 14, CD is 7. Okay. So it seems like a lot of scattered information is given, right? Some part about this angle, some other completely different ratio. So how to connect everything, it is not clear. But to start to use this information, like to use this cos ACB, so opposite this angle, I want to construct a right angle. So the choices are, I can construct the right angle here also, or I could construct it here also, right? So which of the two is better? Uh, we have to think about that. Which of the two will give us more useful information? So,
Sir,
so that
B.
on BC. So I mean the first, the vertical one. Okay.
No, on AC.
On AC. Okay. So this one. Okay. So I know how to solve the problem using both approaches actually. So I'm trying to remember which one is better. Okay, let us proceed with this one. Let us see where we go from here. Okay, so this point is T. Okay. So what will happen here is that, so you know the length of BC. So BC is 14, and you know this cosine. Let not mark it here. So which lengths can I find using this information? Cos of angle ACB is the same as cosine of angle TCB is 3 by 5. So 3 by 5 means, by the way, this is again one thing you should know, that your common Pythagorean triplets like 3, 4, 5, it should be in your mind that immediately when you see the cosine is 3 by 5, which means that you know all the remaining three sides, right? If this is 3 and this is 5, The third side is obviously 4, and this is the angle that is given to you. So quickly you can, so in your mind, this shape should be ready, just to, pick up this shape and put it on your existing diagram. Okay, so here the hypotenuse is 5, so which means this is the 3, right? If I just write the ratios, right? Different color. So these are not the lengths, but these are the ratios of the 3 sides. So this is 5, this is 3, this is 4. So all the 3 sides are in this ratio, 3:4:5. So we can quickly find the length of CT and BT, right? So CT is nothing but 3/5 of the hypotenuse, and BT is 4/5 of the hypotenuse. Okay. Okay, so I found CT and BT. So and also keep marking that what information I've used so far. So I used this cosine, I used the length of BC. Okay, but now what to do after that? So I want to use this other information also, this AC upon AD and CD. This information also I want to use somehow. Okay, so this is the way which I had done this proof. So I want to connect CD also to my diagram, and I want to use this BT also. So what if I construct a perpendicular from this point C like this? Okay. Sorry. This perpendicular set me. Okay. Let us say this is perpendicular. Doesn't look very nice, but yeah, roughly speaking, this is a perpendicular at the base. Okay. Why did I construct this perpendicular? Is because, see, this line is parallel to this line, right? Again, circular diagram, but yeah, it is supposed to be parallel. No, sorry, let me think again. Hmm. So I'm stuck right now. So I don't know if it will come back to me after some time, but let me try the other approach that, okay, this is not working. Then what will I do in the exam? Suppose this happens, that I'm not able to make progress. So then go back to your original decision, that remember we had the choice that which altitude I wanted to drop. So we constructed, in this case, we constructed from point B. Okay, so let us try the other approach. Let us construct from point A instead. Okay, let us see if that gives us something different. So, and sometimes this will happen that, your first attempt did not go as per your plan. So you go back and see what assumptions you made, and can we change some of those assumptions. So now this time what I'm going to do is I'm going to construct the altitude from point A. Okay, and let us see if that helps. Okay, so now again, let me call this point S, let us say. Okay, uh, so now again, what is given to me is this cosine is given. And so now here, see, maybe we are tempted to go by this approach because this hypotenuse BC was given, right? So immediately we obtained some length, but it is not necessary to find the length immediately. We can use variables required. So let us say this variable, this as, this length, if I call it h, right? H for height. Okay, so let the height of that segment be h. Okay, then in terms of h, I can still find the length, right? So what will I get? Cosine of ACB is 3 by 5, right? So therefore, again, if I write the ratios inside with a different color, so therefore these lengths are in the ratio 3 is to 4 is to 5. So therefore, I can find AC as so cosine of ACS is the adjacent base upon the hypotenuse, and the sine of that angle is the opposite side upon hypotenuse. And again, if I know the cosine, I know the sine also, right? By the formula sine square plus cos square theta. Okay. And so therefore I can write, and in this formula I know AS is, I assume that AS is small h, right? Therefore, if I rearrange this, I'm going to get AC is equal to AS into 5 by 4, which is 5h by 4. Okay, so this is AC. And what about SC? From this formula, I'll get SC or CS is equal to AC into 3 by 5. Okay, and AC we just found here. So if I substitute that, I'm going to get okay. So I found this AC and CS. So I think we are making progress because now I know the ratio of AC and AD. Okay, so do you see how the solution might be completed? That I want to connect all this given information. So I know CD is 7. I just found the length of SC as 3h by 4. So I think I'm getting ready to apply Pythagoras theorem in triangle ASB, right? So like if I write that step directly, Pythagoras theorem in triangle ASD will give me AS square plus SD square is equal to AD square. And you see in the entire calculation, the only variable is h. So everything will be terms of h only. So I can solve and get the value of h, right? So AS square is simply h square. Now HD is nothing but SC plus CD, right? So that is 3h by 4 plus 7 square is equal to AD square. And yeah, AD we have not found, but AD we can find because that ratio is given, right? AC upon AD. So quickly on the side, let me find AD is AC into 3 by 4, right? Therefore it is 15h by 16. Okay. Okay. So now this equation has only h in that, nothing else is involved. So I can solve it and get the value of h, right? So if I solve it, wait, before that, let me just check, not making any calculation mistakes so far. So AC is so I found one calculation mistake just now. I don't know why. I thought that maybe I was rushing. So the AD, if I rearrange this, I made a mistake over here. And I should have taken the reciprocal. So this is actually 4 by 3, not 3 by 4. And you know why I thought that I made a mistake, by the way? Because here the denominator is 16 and I'm going to square 16. So I'm going to get 16 square over here. And there's nothing on the LHS to cancel that. So that looked a little bit suspicious to me. So that I thought, maybe I need to go back and check my calculation. Okay. Okay. So now if I solve this, I will get the value of h. We are already out of time, so I will skip this for now, but we'll resume this question next time. Okay. And so I will also think more that how to complete the left hand side approach, because maybe somebody may think about dropping the perpendicular from B instead of from A. Then do we have to abandon that completely, or we can still complete the? So let me think more about that. But yeah, anyway, I think yeah, we can continue next time.
Yes.
Yeah. Okay. Thank you.
Thank you, sir.